All right, so today, if you're just now joining us, you need your Transverse Waves paper and the second paper that goes with it, Transverse Waves Continued, Chapter 4. We're going to cut these out along the solid lines so that we end up with those 5 rectangles, not cutting along the dotted lines. Notice at the tops of each rectangle, there's like a gray shaded out area that says glue this part to, and then it tells you what to glue it to. You're going to put glue only in that grayed out area so that when we are all finished, we end up with a cascading flip book that helps us define each part of the wave that we're looking at. Zayden, it's our science notebooks. Science notebooks. If you don't have your science notebook because you were on vacation and didn't pick it up, that's okay. You can do it on a separate sheet of notebook paper. Haley, do you still have a question, or is your hand just up from the last question?
Mrs. Derek?
Yes.
I'll be right back. I have to go get the printer.
Okay, good luck. And then, of course, we are going to be putting these on page 23 in our science notebook that we are going to title Transverse Waves. That's what we are talking.
I don't know what the page looks like.
So what we are going to do is, and this is the kind of tricky part.
I need to find mine.
We're starting with wavelength and frequency, because frequency says glue this part to wavelength.
I can't really find mine.
You can't find your packet?
No, I can't find my packet.
Okay. I can send you the file, Oak, but not right at this second. Not right this second.
Miss Derek,
Yeah.
are you putting this on YouTube?
Yep.
I don't have this paper in my packet.
Okay.
I'm going to, can you email it?
Just found it.
And I'm going to watch it on YouTube.
Okay, that's fine. I will post the pages to the website so that they are downloadable, and then the YouTube video will be up there as well.
All right,
Okay.
thank you.
You're welcome. Did you guys see how I lined this up? You have to line the bottom part up with the dotted line. So wavelength and frequency.
I found it.
Okay. So now,
right here.
I don't know where right here is. Yeah, you can cut that. So we're gonna glue this part to frequency carefully. Whoa, don't do what I did. I got glue everywhere. Apply glue to frequency. We're gonna line up frequency with those dotted lines and press down. So now I've got a flip flap right here with some blanks. I'm gonna find crest, because it says glue this part to amplitude. Taking my glue, carefully applying it to that grayed out area. These usually go a lot easier when we are together. I understand that. So if it's not perfect, it's not perfect. We don't need it to be perfect. We just need it to be notes. We're gonna line amplitude up with that dotted line. And moving to the last little bit, which is trough. It says glue this part to crest. Applying glue here. lining it up.
My glue walls.
I'm lost.
Pressing it down. And hoping you've done it right.
It's there. I'm confused.
We are going to make sure our glue cap's on. Set this off to the side. Open up our science notebooks to page 23. Transverse waves. Then, using our box cross method, we'll go down. And we're applying this.
Does volume work?
Okay. All right. Now, how do we find the wavelength? So let's look. What is a wavelength? We've talked about this a bunch of times now. What is a wavelength? Yes, if you don't have enough room, you can write it on the next page, Tyler. If we're going to have a wavelength.
It is like the two boxes.
Exactly. It is like these two boxes. It's one complete crest and one complete trough.
Was it supposed to be? I thought it was supposed to be the two center ones.
As long as it is one complete crest and one complete trough. Does that contain one complete crest and one complete trough?
Yes.
How about that?
Yep.
What about that one?
Yep.
Yes. So that could be how we measure the wavelength. This one or this one. Usually for me, because this is a graph, I'm almost always going to start at the origin. We're almost always going to do something closest to the origin, just because that's where all graphs begin.
Okay, I just thought that because pretty much whenever example I've seen of wavelength, it's been
Right. Well, we could even call that, does that have one complete crest and one complete trough?
yeah. If you
Yeah.
put them,
Yeah, it does. So there's a couple of different ways that we could look at this. As long as you have one complete crest and one complete trough, you are good to go. Susan, do you have a question?
No, I was going to say the answer.
Oh, I'm sorry, dear. Wavelength. One complete crest. One complete trough. It's a wave cycle. It is a wave cycle.
So, Miss Derek, can you read that to me again? Because I can't see. It's blurry.
A wavelength is a one complete crest and one complete trough. It is a wave cycle. All right, frequency. What is the frequency? If we look up at this wave, what is the frequency? Skylar.
Like how many wave cycles? How many wave cycles are in 1 second?
Correct. So,
yeah.
yes, no, that is exactly it. So what is the frequency of this wave that we have here? Type it in the chat what you think it is. What do you think it is? Yes, Evan, you're right. It is wave cycles per second. What is it? What are my wave cycles per second? Everybody. It seems like everybody is saying 2. I've got 1 complete crest and trough there. That's 1. 1 complete crest and trough there. This is my 1 second. This graph is indicating 1 whole second. So yes, the frequency is 2. The frequency is 2 wave cycles per second, or wavelengths per second. Okay, and then frequency, as Skylar said, is the number of wave cycles in a 1 second time period. We've been thinking about this like miles per hour. Okay, amplitude. Where can I find amplitude in this wave? What is the amplitude? Lucas. Yes. We defined it on page 22 and on page 21.
The height of a wave?
Yes. Yes. So the height of a wave here is both represented by this dotted line and this dotted line, but not the two together. So we're looking at the top, the crest, the most displacement down to that rest position, that equilibrium. We could also view this. Okay, those are the same thing. Put the same letter next to it because they're the same thing.
Miss Sarah,
Yes,
can I do crest after we're done with this one?
sure.
Yay.
Ethan, I'll go back to wavelength so you can see it. Okay, so amplitude, that's represented by our letter C. Amplitude is it's how high the wave can get. Okay, in fancy science terms, maximum displacement of a wave. Remember in the medium, we talked about those particles moving. Well, how far away they move from being still, that's the amplitude. That maximum displacement. Those particles are moving really far away. They're being displaced really far away from the rest position. And so that's what this amplitude is. Okay, crest and trough are really easy from this point on. We don't even really need to put anything underneath these flip-flaps, really. We just need to be able to draw a picture of it. So, Charlie, you asked to do crest. What is a crest? How am I gonna find it on this transverse wave?
Well, it's the maximum upward displacement. The maximum upward displacement is called the crest. So it'd be the upward displacement.
So what does that mean? How am I gonna find it?
Well, so it'd be like up towards, it said upward, so you know, probably be up here somewhere.
Up where, somewhere?
Like at the top of.
Exactly.
Huh?
That's it. That's the key word. It's the top. It's the top of the wave. So, crest, we don't even need to write underneath it. You can if you want. This is the top of the wave. So, how many crests do I have in this picture? Exactly, Nathan. There's two. One there, one there. It's the very top. It's that maximum displacement. Okay, so we've got our crest there and there. If the crest is the top, what is the trough?
The bottom.
The bottom. It's the opposite of the crest. Exactly, Nate, Evan. So, since we figured out that our frequency was 2, we know that we also are going to have 2 troughs here. So that trough is the bottom of the wave.